If you happen to see my video on this Kobalt 26-gallon Quiet Tech compressor, then you know it had a problem. And that was that the internal regulator did not seem to do a very good job at regulating the pressure when the tool was engaged. So to solve that problem and expand the versatility of this compressor, I came up with this. So if you're interested, stick around. The Kobalt Quiet Tech 26-gallon compressor's built-in regulator had a 35 psi drop in pressure when a pneumatic tool was in use, which isn't doing much regulating at all. So since I like everything else about the compressor, especially its quiet operation, I thought it was worth spending a little more money to correct the regulator problem. So I bought a speed air regulator and water separator that I'm going to add to it. After doing a bit of research, I chose a speed air filter regulator which I bought from Zorro. Its features include 1/4 inch NTP connection ports, a 5 micron filter and water separator, 150 psi maximum operating pressure, 14 CFM maximum airflow, and a 5 to 125 psi adjustment range. The current price is $31.25, which I think is reasonable, and Zorro had the lowest price at the time, although it's also sold by Grainger. I have a link to it in the video description. It comes in a compact box and some assembly is required. Take note that there is an input port and an output port that are not interchangeable. I also bought a set of 1/4 inch Husky universal quick connectors from Home Depot. The gauge will go here. Since the gauge can be attached on either side of the regulator, I have to put the included plug in the side that I won't be using. A little Teflon tape will make an airtight fit. Now for the quick connectors, starting with the male one. The threads on these are already pre-coated with a sealant, which is quite convenient. I just have to add the gauge and I'm done. Now you may be thinking that I'm going to take this regulator and plug it into one of the outlets here behind this regulator. But I'm not going to do that because I don't trust that there are still limitations even with this wide open. I don't want there to be any issues between this regulator upstream. So I've got a different plan. It so happens that the manifold just below the pressure switch has an unused, unregulated high pressure port in the perfect location. Right there. The trick is getting that plug out, which proved to be a big headache mainly because of stupidity on my part. First, I tried a 6mm Allen wrench. So we'll just remove this plug here, or attempt to. Maybe easier said than done.
We need an impact wrench.
I didn't have a 6mm Allen socket at the time, so I used a closely matched Torx bit instead. Didn't budge. Clearly this calls for a good dose of stupidity by using the ball end of the Allen wrench and a piece of conduit for leverage. What could possibly go wrong? Oh yeah, that could go wrong.
God!
A few expletives were in order. Behold the fruits of stupidity. I tried everything to get that hex ball out, but to my surprise it might as well have been welded in there. I would have to get really creative to fix this mess. So I was on the verge of welding a nut on the end of this to see if I could then get it off, but then I thought of one more easier thing to try. And that was to use a rotary grinder to cut a slot in the plug so that I could take a piece of square tubing with a vice grip attached to it, stick it in like this, and use a hammer to tap it out. So if you want to attempt this mod, my recommendation is that you get a set of these. I got a metric hex bit socket set and an SAE set as well. The next time I'm in this situation, I can use them with a breaker bar or my pneumatic impact wrench for a better outcome. The last step was to add a female quick connector to the high pressure port, which was easier than getting that plug out. Just this one mod is worth doing by itself because it greatly expands how you can use your compressor. Besides the obvious use of adding a better regulator, you could use a longer hose to put the regulator closer to the tool for better regulation. Also, a longer length of hose between the tank and regulator allows water vapor to condense before reaching the filter and water separator, making it more effective. You can also use the high pressure port to feed a shop distribution system that allows you to use multiple tools with multiple regulators to supply tools with different pressure requirements. Maybe one of the tools needs an oiler and a higher pressure, but another, such as a paint gun, just needs dry air at a lower pressure. This one inexpensive mod allows all of this and more. So now with our new regulator and water separator in place, let's reproduce that test. With the regulator set to 90 psi, the pressure falls by 20 psi to 70 psi. That's a 22% decrease in pressure. Not as good as I'd hoped for, but a lot better than the 35 psi drop of the built-in regulator, which brought the pressure to 55 psi for a 39% pressure loss. That's unacceptable. Notice the water vapor already collecting in the filter. In this test, I held onto a big socket on the impact wrench while doing the test to have some load on the tool. So in all fairness, I'll retest the built-in regulator. Starting at 90 psi, we see that yes indeed it still is falling by 35 psi. All in all, I think the mod is worthwhile even though the improvement wasn't as much as I had hoped for, which was little or no pressure drop when the tool was operating. The cool thing is that I can always try a better regulator plugged into the unregulated port, and I have a lot more options for connecting tools. If you have any suggestions on ways to improve on this fix for the pressure regulator problem, I'd appreciate it if you'd share them in the comments. If you found this video helpful, I'd appreciate it if you give it a thumbs up, leave a comment, or by all means, please subscribe. If you want to know when I post new videos, click that little bell. As always, thank you for watching, and I'll see you on the next one.